Hello and welcome back to the 8th and final lesson in Unit 2. And in this one we're looking at modeling quadratics. So you will want to have your iPad out and maybe work through make sure you can get everything on your iPad that I'm going to do today. Desmos is a piece of technology. It's an app that is free and you want to make sure you put it on the iPad, or it also works on the Android version as well. Type this into your App Store and it will pop up. I'm going to be using the internet version. I'm going to be using the computer version just because my air server isn't working. So what information do we need in order to model quadratics? Well, this is something you would do in a science class, okay? This is from a science class. All right. So what would happen is you collect data. So one, you run an experiment. And collect data. Number two, the teacher asks you to analyze the data. So for the lesson today, you're going to be provided with the data. I'm not going to have you run an experiment until you do a thinking task, and then you might have an experiment to run and analyze the related data. Okay, so I'm going to switch over to my PC top. You want to make sure, open up your Desmos app. So what's going to happen here, we're looking at a baseball again, follows a quadratic path. Height of the baseball is measured in meters, d, the horizontal distance in meters, so it's like the previous note on Zach. We're measuring both distance in terms of height and how far it traveled in the horizontal, except the data was collected using some piece of technology. So the first step is to make a scatter plot of the data. We're going to do that using, as I said, Desmos. So opening up Desmos. So as you open up Desmos, it's going to look similar to this. All right, so yours will look a little bit cleaner because it's an app. So we're going to enter in that table. So to enter in the table, you go to your pull down item, insert an item, and we're going to insert a table. So you're going to insert your values right here. So now I got to kind of go split screen here for a second. So I see the first one's a 0. I hit enter and it allows me to go to the next one. The app works a little bit different. So we're going to fill out this table. I'm just going to pull my Desmos over here so I can look at the table at the same time. So I just run down and enter the values. So let's do that first. All right, so I've entered the data into Desmos for myself. Just get this to work. So as you can see right now, I can only see one dot. So, well, actually I can see two dots on it, I guess. So what you want to do is you want to zoom out. So you use your finger swipe. You move the graph around, and here is the data collected. So right there is all the information that was collected and provided to us. So A part of the question, I'm going to zoom back and forth here. So A part, make a scatter plot of the data. So we did that. So check. All right. Estimate the coordinates of the vertex. So all we're really doing here is we're just going through, and you can see that if we zoom in a little bit, you don't have to necessarily do that with yours, you can see that the ball comes up high and returns back down. I'm actually going to say if you click on that point, you see how it will highlight the point. I'm going to estimate that the maximum height is 32.9 meters, or that's the vertex. It's going to be pretty close to that point right there. All right, so just clicking on the points will they will show up for you. So I'm going to estimate it to be the 4.1 and 32.9. So let's type that in for B. Oops, let's go a little smaller. So for answer B, the approximate coordinates of the vertex are, bracket, and I'm going to say that it was 4.1, comma, 32.9. All right, there we go. So that has now answered B part for us. Check. Okay, use technology to create an algebraic model for the data. So this is something you're going to want to put on your cheat sheet because you're not going to remember this at all points in time. So here we go. So on your Desmos app, you want to pull down and we are going to insert an expression. All right, so here's my expression box at the top. And we're going to enter in a blank equation because we want it to give us the values. So we type in y, and we want to go with the tilde or the squiggly. So it's usually found in the, where is it found again? Let me find it first here. Oh, found it. So on your, if you hit your ABC, here's tilde. Okay, what that does is it says approximately to. And what we want to now do is, let's put the equation in vertex form. So we're going to use the general form. So I'm going to go A, and then we're going to put some brackets in, and we'll go x minus, oh, maybe it won't let us do it that way. Okay, so let's back that off. Let's just go with ax squared plus, I thought it might do it for us, but it doesn't look like it wants to agree with me on this one. Plus bx, oops, plus c. All right. And what's that? It's not letting us enter the. All right, and I think I know why, because here we have to enter it in as ax1, bx1, and do we need a y1 as well? There we go. Hey, the old brain started working. So all I did was, beside the y and the two x's, I just hit ones. The reason for that, okay, is that when it enters into the computer software, see how up here the x and y have ones for the subscript? So you can put a couple of tables in. If you put another table in, the subscript would be 2. So we had to tell the equation which table of values were we using. So that's why I forgot my 1 for subscript. So I do apologize for that. So anyway, there is the equation, general equation for our parabola. And here are the values, a, b, and c. So we got our a value, our b value, and our c value. So the equation of our parabola is approximately negative 2x squared, so negative 1.97x squared, plus 15.96, or 16x plus 0.55. All right, so there is our general equation. So I'm just going to pull that off so I can answer it over here. So we did that, and the equation will be, let's see if I can get it in here. So number C, the equation of the model B, y equals, so I said I'm going to go negative 2, close enough to negative 2x squared. That's not even going to go superscript here. Crazy guy that I am. Okay, font. That's the joy of doing it from the keyboard. Plus 16x plus 0.56, we'll call it. So there is the equation of our model. And if you had a science experiment, you could enter a table into Desmos, and it will do exactly that. It will come up with an equation that'll model the data, and it'll do other equations, not just quadratics. It'll do lines, different types of curves, and so on and so forth. Okay? Just as a side note, for those that are looking at going into the data management for you course, the r squared value, it's close to 1. That means we have a really good model for our data. Okay? So anyway, back to our question. We didn't see. So D, determine the exact value of the vertex. So to determine the exact value of the vertex, we're going to zoom in. Whoa, where'd my graph go? Come on. And we're going to zoom in. And based on that, there's the vertex. See how the gray dot appears? It's a key point. So all your key points will have gray dots on Desmos. I'm not sure if the x-intercept will. Anyway, that is the key point. So we know the vertex, according to our equation, is 4 and 32. So I would say our approximation was actually the vertex itself. Okay? So we're going to put here D our approximate vertex from part B appears to be the vertex. Okay, doesn't always work that way, but for this example it did. So that takes care of D. Now, how far did the ball travel in the air? So how far? So we need to go back to our graph. I'm going to zoom out. How far? So think of it this way. The nice thing with the graphing, hey, look how clear that is. All right, let's minimize it and refresh my screen. There we go. Think of it this way. The ball traveled here. It's started, it traveled, and then it came down and hit the ground. All right, so it's like watching the ball from the side. It's like the Fox Sports Tracker. And we see this is where the ball landed right here. So we can see that the height is 0. It traveled 8.1 meters. So Desmos will tell us all that information. So how far did the ball travel in the air? Okay, so for E part, the ball traveled 8.11 meters in the air. Okay, so there we go. Graphing technology makes certain things easier. In this case, we can take a table of values and we can do a whole bunch of stuff with it. Desmos will allow you to do that regression. You want to make sure that gets onto your cheat sheet because you'll want to use it when it comes to the homework, obviously, and then the tests as well. All right, and like I said, the other thing you can do for people that haven't used it before, you can put your finger on the graph and just drag your finger, and you can find specific points. It'll tell you the value, the x and the corresponding y value. All right. If you have any other questions with Desmos or with this note, let me know. If not, good luck with the homework, and we'll see you in class.